All right, hi guys. We're gonna get started with trivia in just a minute. For anyone who's here, I think there's just two people here right now. Could you just comment your name below so I know to put you in the draw? And I'll ask again at the end, so if you forget, it's cool. Okay, well, hopefully some more people will join us soon, and we'll get started. First I'd like to ask you guys just a little question. So this week's theme is the elements. So my question for you is, do you have a favorite element on the periodic table? Mine's praseodymium. It's radioactive, and I don't think it has a whole lot of uses, but I think it's fun to say. And it's radioactive, so I mean, I could probably never touch it, and if I had the chance, I probably shouldn't. But I think it's cool, just because it's fun to say, really. I'd love to know if you guys have a favorite element, though. Yeah. Okay, so I think I wrote out the details already in the description, but so you take part in, I'm gonna move myself over here. You take part in this week's trivia, you get a chance to win a $5 Tim Hortons gift card. And we'll do that draw at the end. I will give you the Beanstack code at some point during the duration of this game, and yeah. Okay, so we don't have a whole lot of people, but it's almost 3:05, so we'll get started with question 1. So, does anyone know what the first element on the periodic table is? I'll give you a hint. The symbol for it is H. It's just H. And is the first element on the periodic table. It is lighter than air. So something that floats in air might be filled with this. Wink, wink, nudge, nudge. If you know what I'm saying. Very interesting element. I would say most elements are interesting, but this one is, you've definitely heard this word before, I'm sure. Maybe you don't know it's an element on the periodic table, but you might know it. Okay, so I see an answer. The answer is hydrogen. So I don't know why, but I was thinking helium, is in a balloon, and that is lighter than air as well. And that's the second element on the periodic table. But the first element on the periodic table is hydrogen, so that is just an H. It has an atomic number of 1. In its natural state, it's a gas. It's very flammable. The lightest of all the elements. Was discovered in 1766, and it's also a non-metal. So it is in H2O. I see what you guys are getting. I see a few people said that. There is 2 hydrogen atoms in H2O, which is water, right? We'll move on to question 2. So what elements do mammals need to survive, to breathe in from the air to survive? Now, so it'll just be one element. So it will be one letter. Some elements are 2 letters, but this one is 1 letter. You've definitely heard this word before. You definitely know what this means. I think you guys will know this. I think you guys are going to get it. For sure. You guys know it. Think about it. What do you breathe in that you need in your body to survive as a human being? And I see an answer, and it is correct. The answer is oxygen. So oxygen is what mammals need to breathe in to survive. It has an atomic number of 8, and it's a natural state. It's a gas. It's a, oh, this is so hard to say. It's a it's a halocene. Oh my gosh, I'm not even going to attempt. CHALCOGEN. It's very hard. Chemistry things are hard to say, aren't they? So it's the 8th element, and it was discovered in 1773. Yeah, someone said air. Yeah, oxygen. Most of our air is made up of oxygen. Our air is actually made up of there's some nitrogen and a few other elements in it. Also, carbon, which is something that we will breathe out, and we'll talk about that later. But we'll move on to question 3 for now, guys. So what element is represented by the letter K on the periodic table? Now this one's a bit weird. So if you don't know, the letters on the periodic table don't really correspond to, sometimes they correspond to like the English names, but for the most part, they correspond to Latin names of them. Some of the like newer ones don't as much, but like especially the ones that you know of, most of them actually are for Latin. So like lead is PB, which stands for, this is really funny, plumbum, but that is lead. It's basically lead in Latin. So the reason this element is K, the word that you would note the element by starts with a P, but the reason that it's K is because its Latin word starts with a K, which is really cool. I don't know if anyone will get this. It's a little bit more difficult, guys, but I'll tell you, it's potassium. So potassium is represented by the letter K. It's the 19th element on the periodic table. It's an alkali metal. It has an atomic number of 19. It was discovered in 1807. And there is more potassium in bananas than in other foods, but one banana still only has about 40 milligrams of potassium, and it's not very much. And your body kind of metabolizes it. So where if you had enough pure potassium, it could hurt you pretty badly. It could be deadly. Eating a lot of bananas probably wouldn't kill you, though I don't think I would recommend it because your body will metabolize it and you can't actually get that much from bananas, even though it's one of the foods that has the most potassium in it. We'll move on to question 4. At room temperature, what is the only metal that is a liquid? Here, maybe I'll move nope, wrong thing. I moved the wrong thing. I will move myself somewhere that you guys can see better, maybe. It's better if I put myself here. Does this look weird? Maybe. I think you can see better if I do this though, so I'll leave it like that. So at room temperature, what is the only metal that is a liquid? Oh, I see an answer, and it is correct. And I see another answer, and it's also correct. The answer is mercury. I'm gonna move myself back down. I can't do this. It looks so weird in that part of the screen there. But so mercury is the only naturally liquid metal. Its symbol on the periodic table is Hg. Its atomic number is 80. It's used in thermometers, or old thermometers. I don't think they use it as much anymore. But most mercury is found naturally in cinnabar, which is mercuric sulfide. And in ancient times, cinnabar was ground up to make vermilion, which is a red pigment used in cosmetics. Mercury was also used in other cosmetics, well until we discovered it was dangerous. So for a really long time, because we didn't know it was dangerous, we didn't realize that it was hurting anybody until people had been using it in cosmetics for too long. Made a lot of people sick. I will move on to question 5. Who was the first person to receive a Nobel Prize twice? Now, this is probably my favorite question because we get to talk about someone really awesome, but get this, I will give you a hint, and the hint is amazing because the first person who won a Nobel Prize twice was a woman, and that makes me feel so empowered. So, girls out there, feel empowered. The first person who won a Nobel Prize twice in their lifetime was a woman. Do you know her name? You may have heard it before. You may not know that she won a Nobel Prize twice, or you may not even really know anything about her, but you've probably heard her name before. If you haven't, you will in a minute. I'll give you guys... No, I read as I said that. I saw someone's comment came in and it's the correct answer. So it's Marie Curie. So Marie Curie was the first person to win a Nobel Prize twice. She was Polish but studied in France, where she met and married Pierre Curie. She shared the prize in physics in 1903 with Henri Becquerel and her husband, Pierre Curie. She was awarded another Nobel Prize in chemistry in 1911 by herself for discovering polonium and radium with her late husband, but since her husband was dead at the time, only she received it, so she received it alone. And back then, they didn't know the damage of radiation, so both of them exposed themselves to it a lot, and Marie's belongings are actually still radioactive today. And to view her notes, you have to sign a form and put on a radioactive like free suit, like for safety. It's crazy, guys. I'm serious. Insane. We'll move on to question 6. What is the common element of all life on Earth? You've probably heard this word before, even if you don't really know what it means. I will tell you, it starts with a C, and its symbol on the periodic table is also C, just C. It's the first one with the C on the periodic table. Yeah. It's really interesting because it's the common element of all life because, well, there's a lot of weird, complicated chemistry behind it, but basically it just bonds to things really well. So they call it like it's the common element of anything that's living. And I see 2 answers, and they're both correct. So I will show you the answer. It's carbon. So yeah, the people who answered, you guys were right. So it's the common element of all life on Earth. Its atomic number is 6. It's a nonmetal and naturally a solid. And its symbol on the periodic table is C, which I already told you. And carbon was actually discovered in like prehistory. So it was known in the forms of soot and coal to the earliest humans. So we don't actually have a date of discovery or a year of discovery for this element, which is pretty cool. Question 7. The chemical compound H2O is more commonly known as what? And I already said this earlier. If you guys were listening, you'll know this for sure. I don't know I don't think this show's on anymore, but I used to watch this show called H2O, Just Add Water. It really didn't have much to do with chemistry at all. You think it might? It didn't. It was about these girls that turned into mermaids, but every episode they just kept somehow, every time they touched water they turned into a mermaid, and they just accidentally kept finding ways to touch water by accident, and they got into all these weird situations where they would then just turn into a mermaid, and then they're like and then they had weird superpowers, and it wasn't really about chemistry at all, so I don't really know why I'm bringing it up, but I digress on that. I see some answers and they are correct. It's water. So the chemical name for water is H2O, or hydrogen. It's hydrogen dioxide. You usually just say H2O. So in each water molecule, there are 2 hydrogen atoms and 1 oxygen atom. It has a pH of 7, which is exactly in the middle of the pH scale, making water not an acid or a base, but completely neutral. So if anything above 7, it's acidic. Anything below 7, it is basic. But 7 is pure water. So if you have water that's a little bit skewed to one side, then there's obviously some other things in it, which most water that you drink does have other minerals and stuff in it. So don't be worried about that, trust me. But yeah, you guys all got that, but we'll move on to question 8. What chemical compound do plants need to survive? So I think I talked about this earlier. So we breathe in oxygen, and then what we breathe out, what we breathe out is what plants actually need to survive. So it's actually a combination of 2 elements we've already talked about. I will give you that hint. And plants need it like we need water, or like we need oxygen, the same kind of way. It's a whole weird photosynthesis thing that I'm not going to get into. I could, but I'm not going to because it's weird and complicated, and I don't think I hardly understand it. But you guys have probably heard of photosynthesis, so You need those elements, also the photons from light and stuff, more oxygen than from water, to do this. And I see some answers and they are correct. It's carbon dioxide. Didn't really have much to say about this. We've already talked about carbon and oxygen. So we'll just move on to question 9. But yeah, you guys who answered, you all got it right. So you're good. On the periodic table, there's a group of elements that are non-reactive. What is this group called? So some of them have really weird names. Like you have your halogens and your nonmetals, your alkali metals. There is one just column, which is the like up and down on the periodic table, that is just at the end of it. There's just one column, and they don't react to anything. And so the reason that they don't react is because, trying to kind of put it into more simpler terms, it's a really complicated thing because chemistry is microscopic, right? So it's hard to explain something that's hard to really see. But to put it into simpler terms, it's basically just that atoms have electrons. You probably heard of electrons. They have them around them. And when they form together, it's because they're sharing or taking electrons from one or the other, and that's how they combine. But so this group in the periodic table is non-reactive because all of the spots that it can hold electrons on the outside of it is full. And I see an answer, and yeah, there's a question mark after it. Noble gases? But no, that's right, actually. So the noble gases are in order: helium, neon, argon, krypton, xenon, radon, and unactinium. I've never had to say that one before, so I'm not sure if that's correct. But noble gases don't react with other elements because their electron shells are full, like I was saying. So how chemicals react is they take or give a share at least one electron, so that their electron shells are then full, and that's why they react with each other, so they can keep their electron shells full. And that creates a bond that sticks them together, creating a chemical compound. But noble gases, their electron shells are already full, so they don't react with any other elements. It's pretty cool, isn't it? We'll move on to question 10. What symbol represents iron on the periodic table? I will give you a hint. This is one of those tricky ones, so it's not going to be an I. It's going to be a weird Latin thing, and it's 2 letters. It's 2 letters. So I will tell you that. It's 2 letters. It's a weird Latin thing, so it's not like I, R, or something like that. It is something different. And I can't remember off the top of my head what it stands for, what the actual Latin name is that gave it this name, but maybe you guys will know its symbol. There's 2 letters. Iron is interesting, isn't it? I don't really know what to say about iron, to be honest. I'm sure you guys have heard of iron before. I'm not going to get into it, but I see an answer, and that's correct. So yeah, it's Fe. So the symbol for iron is Fe. It has an atomic number of 26. It's a metal. It's solid at room temperature. And there's no recorded discovery of iron because it's been used since before human records, before we recorded things like that. So the same with, I think it was it carbon? Yeah, but before being smelted, iron actually is somewhat soft and not as hard as the iron appliances that you own, because the ones you own have been smelted. So think of a blacksmith, an old timey one, right? They're hitting metal and heating it up and then putting it in water. That whole kind of there's a lot more to it than that, but that whole kind of process is smelting, and that makes it harder. But when you just have kind of pure iron before you heat it up and cool it down and do that a few times, it's actually a little bit malleable and kind of soft. It's still pretty hard, but it's not almost unbreakable. It's not practically unbreakable like it probably is. The things in your home probably are. We'll move on to question 11. What 2 elements combine to make rust? Again, these are 2 elements that we've already talked about. So this one's a little simpler. So think about what rusts, what kind of things or appliances that you have would rust, and what gets on it to what is the chemicals or compounds or whatever that get on it that create the rust. And I will tell you that. So there are three elements on the periodic table that 2 of them combine to make it, but one of them is what's called a catalyst, and I think it kind of explains it better on the next slide. But A catalyst is an element or some sort of compound or something that isn't used up in a reaction, but because it's being there, it gives energy to the reaction so that it can occur. And there might be a better explanation of it on the next page because I wrote that one out. But two things we've already talked about. And think about the things that would rust and why do things rust? You might know kind of like, oh, you left something out like wet, right? You left out some sort of metal out wet and it rusted, right? What kind of metal did you leave out and why was it wet? Someone said iron and... So yeah, you're half right. So it's iron and oxygen. So rust or iron oxide is a chemical reaction that occurs when water, which is oxygen and hydrogen, meets iron. So water is just a catalyst for rust to form. So the water gets on the iron, and then because there's air and oxygen around it, and then oxygen mixed with the hydrogen, it rusts and rust forms. But the water isn't really necessarily used up because there's enough oxygen around the stuff already to create the rust. But like metals don't rust just sitting out in the room. You need that catalyst of water or else there is no energy for the chemical reaction to occur. So kind of interesting. We'll move on to question 12. So what two elements combine to make table salt? So you may know kind of like, oh, like sodium, like sodium. So that's, yeah. But there's more to it than that actually. When you're talking about sodium is technically salt, but when you're talking about table salt, it's a little different. Like the table salt you consume. Also, interesting thing is I think sometimes in like salt, table salt, so what the answer to this question is, they will put iodine in it as well, just because you need a certain amount of that in your diet, and a lot of people don't always get that. And then what can happen if you don't get enough iodine in your diet is you get what's called a goiter, which is just like a weird big thing on your neck usually. They're not very fun. People don't like them much, and I'm pretty sure, I don't even know if you can get rid of them, but if you can get rid of them at all, it's pretty difficult to do. But so that people often put iodine in table salt. But so yeah, I see an answer, and yeah, it's correct. So it's sodium chlorine. It's sodium and chlorine. So sodium and chlorine combine to make table salt. So the salt's chemical name is sodium chloride, and its chemical symbol is NaCl. It's a simple compound with a 1-to-1 ratio, meaning that there's one sodium atom combines with one chlorine atom to make it. So it's not like H2O where you have one hydrogen atom and then two oxygen atoms. There was one sodium atom and one chlorine atom, and they come together to make sodium chloride, which is table salt. We'll move on to question 13, guys. So halogens, actinides, and lanthanides are all what? So they're all something on the periodic table. They're all something on the periodic table. You will see all of these on the periodic table, but what are they all on the periodic table? What is the similarity between all of these things? They are all one thing on the periodic table. Even though they're different, they are all the same thing in this sense that we're talking about. Any guesses? So we were talking about like columns, and you also talk about periods, but there's another thing. So halogens, actinides, and lanthanides, they like go sideways. So we'll go, so the answer is that they're all groups on the periodic table. Maybe I misled you with that question. It was a little bit confusing, but really I just wanted to take this opportunity to talk about someone said no idea. No, I know, groups of elements. Someone said it. See, the halogens include fluorine, chlorine, bromine, iodine, and acetine. And actinides include actinium, thorium, protactinium, uranium, neptunium, plutonium, americurium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium, and they're all radioactive, just so you know. And lanthanides include lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, I wrote these down and I can't even say them. Dysprosium, holmium, erbium, thulium, ytterbium, and lutetium, something like that. Yeah, that one, I misled you guys on that one. That was my bad. But I wanted to take that opportunity to kind of tell you about the lesser known groups on the periodic table. So we'll move on to question 14. We're almost done here, guys. So what is the name of the chemical reaction that turns food brown when cooked? This one is hard. I honestly I'm not sure I expect anyone to get this, but I do want to talk about it, which is kind of why I put this question in there. I know I'm mean. Sometimes I put questions in just because I want to talk about it. So maybe, I want to talk about it. Not only is it a fun word to say, but it's really interesting that there's just a name for the chemical reaction that turns food brown, like when you cook it, which is really cool. I mean, most food does that. It is French. And I don't know if this will help any of you guys, but for some reason, every time I read it, it reminds me, it's kind of similar to how you say duck in French, if you know how to say duck in French, which maybe you also don't, and maybe that's not helpful. But every time I see it, I think of a French duck. And it's not that, but it's close to that. But I'm not sure I expect any of you guys to get this, but I do want to talk about it. So I will just move on with it and not wait for you guys. So it's called the Maillard reaction. I know if you can read that, it's spelled Maillard, which is funny. It's a funny word. It was a guy's last name, like the guy who discovered it, but I'm pretty sure he was French. So Maillard is how you say it, and it's weird. Yeah, someone said mill something, so yeah, you're close. It's the Maillard reaction. So it's what happens when food browns while cooking. And it's caused by a reaction of amino acids in food. So amino acid like chains, they chain together, and that's actually what make up proteins. I'm sure you've heard of proteins before. So for the reaction to occur, proteins obviously must be present because we have amino acids. And this type of reaction was named after the French chemist Louis Camille Maillard, who first described the reaction in 1912. So we actually haven't had a name for this for that long, despite, we would see it all the time before that, but we never really thought of it as a chemical reaction. But when you bake something, when you put things together and bake them, or when you cook something, it's a chemical reaction going on there, which is really cool. Like cookies, you make cookies, that's a chemical reaction. Think about that. That's insane. So many things you do are just like a chemical reaction. Anyways, we'll move on to question 15. What is the middle of an atom called? And so I will give you a hint. If you guys have learned anything about, cells and cell structure in school, it's the same, what they call the brain of a cell, or the middle of the cell, where you have your DNA and things like that in that little circle in the middle of the cell. If you guys have learned about that, it's the same name as that. It starts with an N, and it sounds kind of funny. But you might know this. I feel like these questions got progressively harder, and I really didn't mean to do it that way. But, here we are. You guys are still doing pretty well, to be honest. I stumped you on a few of those. But I can't stump you on this one. Someone got it. Oh my gosh. Wasn't expecting it. So, yeah, the answer is nucleus. So the middle of an atom is referred to as the nucleus. The nucleus of an atom is made up of protons and neurons. So protons are positive and neurons are neutral. Electrons are what circle the nucleus, and they're negative. So in a regular atom, there's the same number of protons as electrons to the atom. So the atom is neutral, and it's not negatively or positively charged. But so when you have when things come together like a compound, then you can have things that are positively or negatively charged because they have an extra electron or they're missing an electron, either at certain points, because sometimes they share electrons, sometimes they steal them. Depends on the chemical reaction. But yeah, no, I can't stump you guys with this one. So here, I did this at the beginning. I think I missed a few names, but so that's our trivia game for this week. I'm gonna say the names for you guys, just so, sorry, my mouse is being weird today. I'm gonna say the names that I have written down for you guys, and if you could comment your name if I don't say it. So I have Lilia, Odin, Connor, Jonah, Gracie, and Emily. I think I saw a few other people comment their name, but I can't see them in the comments anymore. So I'll read that again. It's Lilia, Odin, Connor, Jonah, Gracie, and Emily. So if I didn't say your name, could you please comment it? Well, I'm waiting for you guys to do that. I will give you this week's Beanstack code. So if you want to get the little badge for this week's trivia session, the Beanstack code is CARBON. So that's CARBON. CARBON. And you can get your parents to put that into your Beanstack code, or into your Beanstack account, and you can get the badge for this trivia session. Okay, I'll read them out again. I think I got everyone now. So Lilia, Odin, Connor, Jonah, Gracie, Emily, Zach, James, Colin, Jessica, Jacob, and Ryan. Is that everyone? I think that's everyone, but I'm just gonna wait a few seconds just to see if I'm missing someone. Yeah, I think that's everyone. So we'll go along with this. I'm just going to use this little app thing that I have up here. You might be able to hear the little clicky things, but it's gonna randomly pick a name for me out of everyone that I put in. Okay, so we've got our winner for this week. Our winner this week, who gets the $5 Tim Hortons card, is Odin. So Odin, you can come down anytime during library hours and get your $5 Tim Hortons card. After this is done, I'm gonna write your name on it and bring it downstairs, so you can come in probably starting in like 10 minutes after this session ends, because I'll do that right away. But yeah, congratulations, Odin. So yeah, you get your $5 Tim Hortons gift card. Isn't that fun? Yeah, so that's really it for this week, guys. I do have a little thing here if you want to take a look at. We have a YouTube playlist for Elements Week. We've got a book list, and I have some little movies here. So like Big Hero 6 or Meet the Robinsons on Disney Plus, and there's also Chitty Chitty Bang Bang on Prime Video. Yeah, just some suggestions if you're looking for something to do. So the YouTube videos are kind of educational. The books, some of them are educational, some of them just kind of fit the theme and are fun. And the movies are educational, or some just fit the theme and are fun. So yeah, but that's really it. So the Beanstack code again is CARBON. That's CARBON. Put that in your Beanstack account, and you can get your Beanstack badge for week 7 trivia. And again, congratulations, Odin. So yeah, come down to the library anytime during open hours to get your $5 Tim's card. Isn't that fun? Fun. Yeah, so that's it for this week's trivia, guys. But yeah, if you're wanting to check out any of the YouTube videos that we have on the, we have playlists on the channel for previous weeks as well, if you want to check those out. Book lists for previous weeks, you can find them on Beanstack or on BiblioCommons. And we have some movies. Why couldn't I think of the word for that? We have some movies that just kind of fit the theme. Yeah. So I guess I'm gonna sign off for this week. We'll be back next week again with more trivia. Hopefully I'll see you guys at this Thursday's Zoom. If not, hopefully see you at the next trivia. And I guess I'm gonna sign off now. Okay. I'll see you guys soon, hopefully. Bye.